In this tutorial I'd like to show you how we can call on a couple of techniques to deal with any problematical artifacts that may be visible on a CCD image. These can take many forms. We occasionally come across hot pixels, which are recorded as just pure white pixels, or dead pixels, which are recorded as just pure black, and they don't really contribute anything to the data content of an image. Something that's slightly more problematical to deal with is a defect known as a dead column, or a column defect. And on the image on the screen, if I zoom in, you can see what we have here is a column defect which is 1 pixel wide, but it's just recorded as a bright white line, and it's a bit detrimental to the overview of what's a really nice image. As we go through this tutorial, I'll run through 2 different techniques we can use in 2 different programs. We'll start with Photoshop, and then later on we'll look at a more complicated procedure using PixInsight. But the great thing about Photoshop's option is it's very quick and easy to apply. Now, the thing to bear in mind is that when there's a column defect on a CCD camera, it's generally just 1 pixel wide. But when the images are stacked together, if there's been any shift during the course of the exposure, and this is generally just a pixel or 2, which is actually quite common, that defect tends to get spread out into wider than a single pixel. It can amount to sometimes 4 or 5 pixels wide, and I think it's a little bit more difficult to deal with. The image on screen just shows a sulfur 2 exposure, just a single 10-minute exposure, and that just shows the column defect to be literally just 1 pixel wide. But what we'll do, we'll start off with a stacked image of the same target. This is the Eta Carini Nebula that was taken with the Telescope Live Australia 2 telescope, which is a Takahashi FSQ 106 refractor. And it produces great images, but on the right hand side is the column defect, and because it's made up of stacked images, the column defect is registered over more than a single pixel, in this case about 3 pixels. There is a quick and easy fix, but the thing to bear in mind when you're using programs like Photoshop to correct a column defect, you're actually changing the data content of the image. And there's something we really don't like to do as CCD images. We prefer to just extract details from images without actually putting anything in that wasn't in the original image. But of course, if you're planning to print out a masterpiece image of a nebula or a galaxy or something like that, you really don't want to see these horrible column defects in colour on the image. So it's fine to apply this quick fix to the image just to hide the worst of the column defects. And the way we do it is to just draw a quick selection around the defect. So we can go to where the defect starts, and then we can just come across to Photoshop's Select tool, and we'll draw a selection around the defect. I've made it actually slightly bigger than the 3 pixels of the column defect, and this does seem to actually work a little bit better. Unfortunately, scrolling right the way down to the bottom of the image, I'm just going to move that over so it's more or less centralised on the column defect. Once that's selected, it is a little bit distracting, so as always I'm just going to use the keyboard shortcut Control H to actually hide the selection. Of course it's still there, but it's just gone from the screen because we don't need to see the distraction of the so-called marching ants. So now with the column defect selected, we have one more thing to do, and it's to access the Fill menu, and we do that under Edit at the top of the screen, and then come down to Fill, and it brings up this Fill menu, and when it opens on the screen it may just default to something like this. But what we have to do to attain a level of success, we come up to where it says Contents, click on the arrow and select Content Aware. Now all of these other options on the screen are completely default. We don't need to change any of those, so I'm just going to click OK, and you can see on the screen quite successfully the worst of that column defect has been eradicated. Now what Photoshop has done is carried out quite a comprehensive analysis of the pixel values within that selection, and it's filled them in to remove the column defect, but of course it's probably put in false stars and possibly some other artifacts as well. But as I zoom out on the image, it's possible to see quite clearly that the column defect has been somewhat eradicated. If I go back to where we started and just click back to this earlier state, I'm just doing this off screen using the history menu, and then come forwards again, it has done a very good job. It's quite possible that if you don't carry out this processing on the individual stacked master frames, when you come to combine your three images into a colour file, you'll find that the column defects become multicoloured and actually become a little bit bigger. So if I call up on the screen a colour version of the Eta Carina Nebula, and this is an image that's been produced using the Hubble palette. So we just in this case loaded sulfur 2 into the red channel, the hydrogen alpha into the green channel, and the oxygen 3 into the blue channel, and that gives us a nice colour image. But lurking on the right hand side is the column defect, and this time it's a bit multicoloured. So the good news is we can actually just use the same technique as before. We call up the selection tool, just going to draw a selection around the worst of the column defect. Again, we can make it a little bit bigger than the actual defect. I'll hide that once again using Control H, and this time we'll do the same thing again, just call up Edit Fill, and it's remember the content aware setting, click on OK, and after a short period of time on the screen it's done a fairly good job of hiding that column defect. But do just bear in mind that we are putting in false data into the image, but if you're just using it to print out or put on a website or something like that, this is perfectly okay. Now we can switch over to using PixInsight, which is a very powerful tool for correcting column defects. The first thing to do is to actually open one of the subframes that contains the defect. And this is a hydrogen alpha image, just a single 10-minute sub exposure. And the column defect is quite obvious here on the right hand side of the image. This is just hydrogen alpha exposure. The first step of the process is to actually locate the pixel coordinates of the column defect. So by zooming in and placing the cursor over the column defect, we can get a readout of the column's position using the values down here. So by carefully placing the cursor in the middle of the defect, we can see the first number at the bottom, 3562. And this tells us the left to right position of the column defect. But while we're here, we can also make a note of the top of the defect using the numbers just to the right of the previous one, and we can see the figure there is 1724, and then scroll down to the bottom of the image, and right at the very bottom the figure we have is 4095. So always write those figures down for the next step of the process. And to access that, we're going to use PixInsight's Cosmetic correction tool, and that's accessed under Process, All Processes, and then scroll down to Cosmetic Correction. You can see the menu on screen here. The first thing we need to do is add the image that we'll be correcting, and it's the one that's shown on the screen. Once again, it's just a single 10-minute sub-exposure. As we come down the Cosmetic Correction menu, the next thing we come down to is the output directory, and this is just the location of the corrected file. Once PixInsight has carried out its work, it will place the corrected file in the directory of our choice, and I've just left that on the same as from where I opened this image. If we come down to use auto detect, and we should make sure that both hot sigma and cold sigma are both ticked. The default setting is 3, and that does seem to work quite well, so I won't change that at this stage. And then the next thing is to use the defect list. Now it's here that we have to input the values that we wrote down earlier on. You can see they've already been done here. On the left we have the value 3562, which is the horizontal position of the column defect, and once that's been input we make sure we select column because we're actually dealing with a vertical column. Over here there's a tick next to the word limit, and I believe this is where we can set constraints on the height of the column defect to be repaired. And if you remember, just recently we marked the top and bottom positions of the column defect, and the numbers I wrote down were 1724 or 1722 and 4095. So this is the point here, and 4095 was the point right at the bottom of the CCD array. Now once all this information has been loaded into the menu, you have to remember to click Add Defect to get this information stored up here on the defect list. And then once that's done, just click on the blue circle to apply the correction, and after a short time PixInsight will apply the correction and save the new file to our directory of choice. So that's been done. Now we can open the image, and here it is. Apply the auto stretch, and now we've got a nice clean image, so we can close that down, zoom in, and that's it. It's done a very good job of correcting that column defect. Of course this technique has to be applied to all of the individual sub-exposures. The same values can be used because the column defect is in exactly the same position on the CCD sensor. So you can load all of the files at the same time and carry out the correction all in one go. And PixInsight will apply the correction to all of the individual frames and then save them in your directory of choice, and then you can carry on to align the images and stack them in the usual way.